Hello, everybody. Okay, let's go ahead and finish up chapter 15. Here are the solution sets for the homework assignment. All right. So we have the first one. Find the volume of tetrahedron shown using the order of operations dz, dx, dy. The tetrahedron is bounded by the planes c equals 0, y equals 20, x equals 0, and z equals x minus y. Okay, let me put that here. All right. So we have c equals 0, y equals 20, x equals 0, and z equals y minus x. And if we look at our picture here, point says y is 20. This space is the z y minus x. This is the object D. So that's y equals 20. We don't know that yet. And this line here is the line y equals x. So since that's 20, that's got to be 20. Right, so now we're going to look at the bounds of integration. We want to know the volume. It wanted us to do dz, dx, dy. So what we have to do first is look at the shadow that's on this plane, the xy plane. So from that plane, we do a vertical line. That's M. That tells us the bounds of our, this is parallel to the z-axis. That tells us the bounds of our z component. So it starts at the bottom here. Since the shadow is on the xy plane, so it begins at 0. And it goes up until it reaches this plateau here, and that's where it exits, which is the line z equals y minus x. So that is that bound. All right, then since the next one's dx, perpendicular to there, we draw another line going through the point. That's our line L. So from this was the first point it enters our function, depending on where you pick it. It enters here, exits here. So the soonest it could be, the smallest it can be on our x is 0. And it goes all the way to our line. Because we need to have it in functions of y. This first one has to be in functions of x, y. The second one has to be in functions with respect to y. And the last one is our bounds for our y, which are from 0 to 20. Actually, we have to look for a line that's parallel to our x. This is for x. For this one, it's easier to look at this way. It starts off on 0 and it goes on to the y. All right, so now we begin. Now, I don't know why this one said use that one. Since dx is our middle integration term, it's got to be parallel to our x-axis. As in the first one, so as dz, our m has to be parallel to our z-axis. Dx has to be parallel with our x-axis, so it starts 0, ends at that. I don't know why they put the L that way. So let's begin. The integral of z, of 1 with respect to z, is z from 0 to y minus x. To y. So it's going to be y minus x minus 0. So 20. Next one, we integrate with respect to x. All right, so integrating y with respect to x, you get yx minus x squared over 2 from 0 to y. So the first one, x is y minus y squared over 2 minus 0 times that, so it's minus 0. It's equal to 0 to 20 y squared minus y squared over 2. This is the same as 2 over 2. So 2 minus 1 is 1 over 2. So we take out the fraction since it's a constant. The integral of y squared is y cubed over 3 from 0 to 20. (20 to the power 3 over 3 minus 0. Two, 3, so it's 8 with 3 zeros. 2 times 3. 8, there's 2's and 8 4 times. As far as we can go. Okay, so what it wants as our answers, we want our bounds. So the bounds of dz are 0 to y minus x. So dx is 0 to y, and dy is 0 to 20. And our final answer was 4,000 divided by 3. That's the first one. Let's look at number 2. Evaluate this triple integral dx, dy, dz. Let me write it down. Integral 0 to 1 0 to 3 pi (0 to 3 pi) y cosine z dx, dy, dz. Okay. The first bound of integration is with respect to x. So since there's no x there, we put one there. From 0 to 3 pi, so anywhere seeing x, I put a 3 pi. So it's going to be 3 pi y cosine z minus 0. So the next thing we have to integrate, so it's just 3 pi y cosine z dy dz. So now we got to do it with respect to y. Y becomes y squared over 2 from 0 to 3 pi. So since there's y, it's going to be 0. So it's just the first part, which is 3 pi squared over 2 cosine z. Okay, well, all this stuff is a constant. So it could be brought up. 3 squared is 9. 9 times 3 is 27. Pi times pi squared is pi cubed. So the only thing we have left to do is the cosine z. The integral of cosine is sine from 0 to 1. Sine 1 minus sine of 0. Sine of 0 is 0. And there's our answer. Because whatever sine 1 is going to be in radian measures. That's number 2. Let's look at number 3. Where's number 3? There's Here's the region of integration for the integral. -8. That's dx, so that's beginning and the end. dy is y squared to 64. So the curve is y equals x squared and ends at 64. And from 0 to 64 minus y, that's dz. So we know our formula is 64 minus y minus z. Yeah, which is what it tells us. So now let's look at this first one. dz, since it goes on the plane, the shadow goes on the plane yx. So there's a line going straight up for our m. It has to be parallel to the z-axis. So it starts at 0 and it goes all the way to our line here. So we have to solve it for z. So z equals 64 minus y, which is where we got the top bound. Then the second one is dy. We have to go to a line that's parallel to the y-axis. It comes in touching that line first, which is the y equals x squared line, which is why it's x squared, and exits at 64. And the x, since that's 64, that's y. So what squared is 64? So square root both sides, it's 8, plus or minus 8. Right, so that's what we have to do with all of these. So we have to look at the same thing. Here's 8. There's -8. Let's see, that's 64. So it's a parabola on the xy plane. And it goes up to 64 here. So that goes down. So this next one. So it starts off as this. We have to now switch all of them. So we have to, since this next one's, look at the last two, and that's where our shadow goes on the YZ bound. So the YZ bound has to be parallel to the X or the Y axis. So from this plane, the shadow is back here. So we make it perpendicular to that, going parallel to the Y axis. So it first hits the graph here on our line y equals x squared and exits some point here on the slope, which is, remember, solve for y, we get 64 minus z. The next one is dz. It's got to be parallel to the z-axis. So it starts here on 0 and it goes up. Okay, so now for the surface curve, we know that it equals 64 equals y plus z. Well, we're solving for z. So we have z equals 64 minus y. What does y equal? Y equals x squared. So it equals 64 minus x squared. Because remember, the middle term has to get us ready for the last one, which is dx. And dx, it goes from -8 to 8. Now the new one, dy. So we already got dy. That's going from, well, actually, what's this? Dy dx dz. So dy, it's on the dx dz. The shadow's back here. Perpendicular to it, parallel to the y-axis. It touches the curve first, which is at x squared, and exits the curve somewhere here, which is 64 minus z. Now we have to be parallel to the x-axis. So it has to be parallel to the x-axis. So it's got to cross on these two points here. We have to solve it with respect to z. Okay, so from here, we already know that z is equal to 64 minus x squared. Let's solve for x, because that's what we need. So x squared equals 64 minus z, square root both sides. So our bounds of our x are from positive negative 64 minus z. My headphones need to be recharged. Okay, where was that? Oh, yeah, so our dx goes from negative radical 64 minus z to positive radical 64 minus z, because the variable has to be the last one, which is z. And z goes from 0 to 64. Okay, the third one. We're going dx, dy, dz. So it's on the dy, dz plane. It's got to be parallel to the x-axis. This is our m. So what we're looking at here is this curve. Since y equals x squared, we have to solve for x, because we have to get ready for z and y anyway. So x is equal to plus or minus square root of y. So negative square root of y, positive square root of y. The next bound of integration is we have to look at with respect to y. This one's got to be parallel with the y-axis. So it'll hit it at 0 and exit through the surface. Where's that? 0. And so it's solved for y. So we need an answer with respect to z, which is 64 minus z equals y. And that's what we're doing there. The last one is dz. Again, dz starts at 0, goes to 64. Well, pretty much the last one for all of these, since it goes from 0 to 64, we can go ahead and fill those in. Now, the only parts we have to worry about are dz dx and dx dz now. Okay, for the next one, let's redraw the graph. There's -8. There's +8. All right. So now for the next one, we look at in terms of dz. So we want it to be parallel with the z. So if we do a purple, remember the shadow is on the zy axis, which is this one back here. So to find the dx, it's got to be perpendicular to it. And since it goes this way, it enters at negative radical y, exits at positive radical y, because x is equal to y squared. So it's negative radical y, positive radical y. Now dz, this function has to be perpendicular to the shadow. It has to be parallel to the z-axis. So it starts off at 0 and exits the curve on this face, which remember, which now we have to solve for z because we want a function of y. So it's z is equal to 64 minus y. That's that face. All right, the same logic here. First off, we're going to look at our plane is our shadows on the xy plane. So our m goes vertical, has to be parallel to the z-axis. The z-axis begins at 0, and it exits on our plane, which is this equation. Because we have to have a function with respect to x and y. So we have 64 minus y, since it has to equal z. Now, the next one has to be parallel to the x-axis, so it has to go this way. That's our line L. Again, the only equation we have for the x is this one. So x is equal to plus or minus radical y. Minus radical y to positive radical y. So that's how you look at the transformations of bounds when you ever look at those. What I would do for practice, if you go on MyLab Math, and if you try it once, then you can always ask it for more questions, and it'll give you another set of questions. You can work those out. All right, number 4. Find the volume of the region bounded by the cylinder z equals y squared and the xy plane that is bounded by the planes. Okay. Let's see what all this stuff tells us. This is question 4. The cylinder C equals y squared, and it's bounded by x equals 0, x equals 2, y is -2, and y is 2. Now, these just told us our bounds for the x and y component, and this tells us that. That's pretty straightforward. So it's y, our x, and our z. Positive and negative on the y-axis. So at -2 and 2. So and it goes out 2. It goes up. And it's a parabola. The z equals y squared. So let's look at our bounds of integration. And we're dz dy dx. Let's look at that first. All right. So what is our z? Only thing we know is z, parallel to that, starts at 0, and it touches the curve y squared. Now the next one has to be parallel to the y-axis, has to go this way. So it enters the graph at -2 and exits the graph at 2. And then the x components are from 0 to 2. Right, so now let's go ahead and start integrating. We do the z first. 0 to 2. So the integral of 1 is z from 0 to y squared. -2 to 2. So z becomes y squared minus 0. Now start with dy. Z is y squared minus c0. So we have y squared. So the integral of y squared with respect to y is y cubed over 3 from -2 to 2. So that's going to be 2 cubed over 3 minus -2 cubed over 3. So 2 cubed is 8. -2 cubed is -8. So we have 8 over 3 minus -8 over 3 dx. So that becomes a plus. So it's 16 over 3 dx. That's a constant. So the integral of a constant is just x from 0 to 2. 16 times 2 over 3 minus 0. And our volume becomes 16 times 2 is 32 over 3. That's the volume of our cylindrical rectangle. Let's put those answers in. 32 over 3. Okay, number 5. Find the volume of the region bounded by the coordinate planes in the plane y plus z equals 2 and x equals 4 minus y squared. Y, x, and z. So we have a point out here, point there, and a point there. Just a straight line. That those two touch, and those two touch. All right, let's look at the bounds of integration here. Well, we know since this is already on the ground, let's make the xy the shadow. But it's already there. And that's just a rectangle, makes it easier for us to work with. Since that's our shadow, we have to have dz. Then let's do xy. We could do yx, but since x is a rectangle, it makes it much easier to look at. So now for our integration bounds of the first one, for the z aspect, if we look at this, the z, it begins at 0. Actually, they all begin at 0 because they go against the bounds, the axes. Since that has z, we want a function of x or y, and we use this one. Solve for z. Z equals 2 minus y. That's the z bound. Next, we need a function with respect to x. Well, we have that. It has to have a variable y, so that's already set up that way. So it's 4 minus y squared. Now this last one, what are its bounds for y? How far does it go? Well, when z is 0, at that point, when z is 0, x goes to 2. Likewise, if x is 0, so y squared equals 4, y equals plus minus 2. You can't have a negative, so it has to be a positive 2, since we're in the positive first octant. All right, so let's go from there. The first thing, bound of integration with respect to c. integral of 1 is z from 0 to 2 minus y. Just a side note before going further. You could put them in any order you want to, but sometimes it'd be more difficult than if you chose another one. So if you start a method and it gets too difficult down the path, stop, redo the bounds, and try again. As we saw earlier with that cosine e to the power z y squared. All right, so 0, 4 minus y squared. 2 minus y minus 0, it's 2 minus y dx dy. Now we take it with respect to x, which is going to be 2x minus xy from 0 to 4 minus y squared. Since they both have x, the second part should be 0. We don't have to worry about that one. So it's going to be 2 times 4 minus y squared. 4 minus y squared times y. Makes it 8 minus 2y squared minus 4 plus y squared. Oops, 4y y cubed. Forgot that y out there. Okay. Now we have to integrate each part with respect to y. Well, yeah, okay. You could, for aesthetics, put them in decreasing order. To make it look more professional, or you just do it straight up because it's going to be the same answer at the end. It's whatever you like. So the integral of y cubed is y to the 4th over 4. Y squared is y cubed over 3. Y squared over 2. And 8y, all from 0 to 2. Again, we don't have to worry about the zeros since they all have y's. The next part will be 0, so just the 2's. 2 to the power 4 over 4. 2 cubed over 3. 2 squared over 2. 8 times 2. Two to the 4th is 16. 2 to the 3rd is 8 times 2 is 16. 2 squared is 4. That's not 4. It's a 4, not a 2. Ooh, be careful about that. 2 squared is 4. 4 times 4 is 16. Okay, at this point, we can either simplify all these things and then get a common denominator, which I suggest, because if not, the LCD would be 12. It'd be ridiculously high. So 4 goes into 16 4 times. 2 goes into 16 8 times. So 16 minus 8 is 8, plus 4 is 12. So we have 12 minus 16 over 3. Get a common denominator, which is 3. 36 over 3 minus 16 over 3 is 20 over 3. So that answer goes there. Okay, now where's number 6? Ah, here they are. Number 6. Find the volume of a tetrahedron in the first octant bounded by the coordinates of the plane. Okay, let's stick with this one. So whenever you're given just the coordinates, then we got to use the cross product or to find the matrix size. So number 6, we have the points 4, 0, 0, 0, 1, 0, and at 4, 0, 0, we have a point. At 0, 1, 0, we have a point. And at 0, 0, 2, we have a point. Connect the dots. And there's our tetrahedron. All right, so in order to be able to solve this using triple integrals, we have to find the vectors that define it. So this is looking for the volume. dz dy dx. So we have to first find the bound for dz. Find the bounds of z. So we pick 2 points. We want to use the ones that don't have z because it's going to be like the shadow. Since we're on z, we want to use the x and y components so that we have those. So we have to find v. It's made up of 4, 0, 0 minus 0, 1, 0. Because this is the difference of the two we want. 4 minus 0 is 4. 0 minus 1, 0 minus 0. All right. So there's our x with our y. Now we want the X. This is the X and Y. Now we want the X and Z because we want them to be normal to each other. We're looking for the normal vector. So we want vector W. 4, 0, 0 minus 0, 0, 2. Four minus 0 is 4. 0 minus 0, 0. 0 minus 2 is negative 2. Okay, so we have our two vectors. We have two vectors. Now we got to find our normal vector to it. We'll call it n. Because we need this to find the equation of the plane. So our normal vector is v cross w I, j, k. Let's find the determinant from there. So it's 4, negative 1, 0. 4, 0, negative 2. And you can use whatever method you want to find the determinant. So negative is positive. 2 times 1 is 2i. 4 times 0 is 0, j. 4 times 0 is 0, k. Now minus this. Negative 2 times 4 is negative 8, so it's positive 8j minus 0i minus negative 4, which is plus 4k. Two minus 0 is 2i. 0 plus 8 is 8j. 0 plus 4 is 4k. All right, so now that is our normal vector. We want it to, we're trying to get to the equation of the plane. So since we use the x component, we want to use that point again. So what we're going to do is find the normal vector dot x minus x sub 0, which is 4, y minus, remember the point here is 4, 0, 0. So it's 0, j, c minus 0, k. So n is the vector 2i plus 8j plus 4k dotted with x minus 4i, yj, zk. solve this equation. So 2 times x minus 4 plus 8 times y plus 4 times z. So we get 2x minus 8, 8y, 4z. Now, remember, our first bound of integration is z, so we have to solve for z. So we have 2x minus 8 plus 8y plus 4z equals 0. Solve for z, move everything else over. Four z equals negative 2x plus 8 minus 8y. Divide each term by 4. Negative 1/2 x. That's a minus, plus let's move it over. Minus 2. No, it's going to be plus. That's the constant. Minus 2y. All right, so let's put this in. So that's our limit to z. Where's my first page? So that's the first bound of integration from 0 to that equation. Now we have to find the bound for y. Step B. The bounds of y. When z equals 0 and is parallel to the y-axis. Remember, we're on the xy plane, which is the shadow. So the first one was perpendicular to the shadow. That's why I have to find the normal. This one just has to be parallel to the y-axis. Right? Where's our graph? That should. So parallel to the y-axis. So we know it starts at 0. That's where it enters. It goes, and we have our points. We have our points, which are the 4, 0 and 0, 1. All we need are the X and Y components, because we only deal with X and Y's now. Find the equation of the line that goes through this. So the slope is -4. 1 minus 0 is 1. 0 over -4. The slope is -1/4. The y-intercept is 1. So that is where it exits. And exits at y equals -1/4 x plus 1. That's that face right there. So that's our second bound. We know it starts at 0 and goes to -1/4 x plus 1. Lastly, we find the bounds of x. Yeah, and we know what the x is because it starts at 0 and it goes to 4. So that is our now we find v from 0 to 4. 1/4 x plus 1 -1/2 x 2y plus 2 dz dy dx. All right, so let's go ahead and solve this one. That's our initial question. First thing I'm going to do is find the integral for z. Which is just c. From 0 to -1/2 x minus 2y plus 2. X. Remember, since we're the first one we're integrating with dz, so our bounds can only have x and y components. The next one is y, so the only variable it can have is x. Each step down, one variable disappears. Okay, so I don't need that anymore. 0 to 4. Now this one is just going to be that. Since it's 0, we just have to put that down. All right, now we take the integral with respect to y. So the integral of 1/2 x with respect to y becomes 1/2 xy minus 2y² over 2 plus 2y from 0 to negative 1/4 x plus 1 dx. This is where it gets large. Again, since that's bottom 0, we don't have to worry about that, just the top. So in order to see y, we plug in 1/4 x plus 1. 2's cancel. 1/4 x plus 1 squared. Negative 1/4 x plus 1 dx. Negative times negative, quick distribute here. Negative times negative is a positive. 1/2 times 1/4 is 1/8. X times x is x squared. Minus 1/2 x. That's the first one. Here we have to do the FOIL. So negative 1/4 times negative 1/4 is positive 1/16 x squared. Two times negative 1/4 is 1/2 x plus 1 squared. Just 1. Positive negatives and negative. 2 times 1/4 is 1/2. Positive times positive is positive. Let's clean this up the best we can. 1/8 x squared, 1/2 x. Distribute that negative sign. 1/16 x squared plus 1/2 x minus 1 minus 1/2 x plus 2. Negative 1/2, positive 1/2 cancel. I can combine these two. So this would be 2/2, so it's 2/16 minus 1/16 is 1/16, so I combine these two. So it's 1/16 squared minus 1/2 x plus 1. Yeah, I'll leave it the way they are. So the integral of x squared is x cubed over 3 integral of x squared over 2 plus x 0 to 4. Since that's 0, doesn't matter. Now it's just top. We have 4 cubed over 16 times 3. Four squared over 2 plus 4 minus 0. So this one is 4 times 4 times 4. 4 times 4 is 16. So we have 4/3. 2 times 2 is 4. So it's minus 4 plus 4. The answer is 4/3. Just think all that just for that small number. So the volume of that is 4/3. Okay, this is the last one. If it's any indication, it can only get more difficult. So number 7. They gave us the bounds of integration. Five xz we do one like that already? Oh well. Okay. Again, since there is no integral, I thought I told this earlier. Since there is no integral for e to the power of anything with an exponent, we got to change the order of integration. We can't take with respect to y first. So it'd be easier since doing x here and no x there. So it'd be easier if we integrate it with respect to x first. Because it'd be easier if we get rid of that. Because in order to have a derivative here, we have z. We just need to have 2x or 2y in front of here somehow. So that's why if we do the integration with respect to x first, then we can get a y value there, and then it'll be easier to do the integration. So now that we have this, we change the bounds. Let's look at our graph. It just gives us that. So we know since this is respect to y, it goes from 1 on the y-axis, it goes from 1 to x squared. So this is going to be a parabola type. Because that was the original bound. So if you look at it this way, it enters y equals x squared and exits 1. So we have to, since we're doing x first, we have to solve for x. And it's only in the first octant, so we just take the positive of it. Okay, so since that's up here, our y value goes from 0 to the radical y. But it has to be parallel to the x-axis. So starts at with respect to y starts at 0 and exits at x equals y square root of y. Now with respect to y, has to be parallel to the y-axis. Well, this soonest to enter is that exits at 1. And the z, that's never changed. Z was from 0 to 1. So if a slice of cheese. Yeah, so the y goes from 0 to 1. The z goes from 0 to 1. And the x. So this is our bounds of integration. We first take it with respect to x. So it will be 5x squared over 2 from 0 to square root of y. Since there's an x at 0, this whole thing goes 0, we have to do stop. So we have 5 square root of y over 2 minus 0. So we put 0 in there, the whole thing's 0. It's x squared. Right, so that becomes 5y over 2 z e z y over y to power squared. Okay, now you follow along, because the derivative of e z y squared with y is the derivative of top is 2y z e to the z y squared. So to make this a true derivative of that, I got to put a 2 here. That means I could put a 1/2 out in front. I'll just put a 1 in there. All right, so now you see, now we have the EU du. The derivative of that is 2yz. So now we have the perfect, this is a constant, we can pull it all the way out in front. So now we take the integral with respect to y, which is simply, take that out, it's going to be e because the derivative of this gives us that. Okay, now since our exponents, we're doing this with respect to y. We're doing this, so we have to look at both the 0 and the 1. z times 1 squared minus e z times 0. One squared is 1, so it's e to the power z. Z times 0 is 0, e to the 0 is 1. Yeah, see, so there are times when you do have to take both upper and lower bounds, even if it's 0. And this is the example when it happens. When I put x, this is dc. This is supposed to be dz, which we have no more x's anywhere there. We just have a z. Yeah, if you look at dy, dx, dz. I don't know why I changed the last one. I changed the first two. So the integral, so it's 5 over 4. The integral of ez to the power, or with respect to z, is simply ez minus z from 0 to 1. So we have e to the power 1 minus 1 minus e to the 0 minus 0. So it's just e minus 1 minus 1, that's 0. So the answer is 5 over 4 e minus 2. That's our answer. Okay, I hope that helped. Good luck, everybody. See how far we get in chapter 16.